Okay, hello everyone. My name is Infantri Siahaan, and I am a mechanical engineering student in Udayana University. And now I want to presenting a topic with the title Steel Products and Properties. Let's begin. The main reference I take for this topic is from Metallurgy for the Non-Metallurgist book, second edition, by Arthur C. Riordan. First is introduction. There are many varieties of steel such as plain carbon steel, high-strength low alloy steel, stainless steel, tool steels, high-speed tool steels, merging steels, and precipitation hardening steels. And so, the purpose of this chapter is to introduce the various types of steels, compositional category, and effect of alloying on properties. So that's the purpose why we discuss about this topic. First is classification of steel. There are three very broad-based categories of steel based on composition, like plain carbon steel, low alloy steel, and high alloy steels. However, it is important to point out that steels are classified in many other ways, like the example like this. How many points here? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 points. We see the steel making method. The first is the steel making method, such as open heart, basic oxygen process, or electric furnace method. Second is the deoxidation practice during steel making. For example is keel, semi-keel, cap, or rim steel. Third is the solidification method, such as ingot casting, continuous casting, or component shape casting. And then the mill product form, like bar, plate, sheet, and another. So there are finishing method, such as hot rolling or cold rolling. Next is microstructure, such as ferritic, pearlitic, and martensitic. There are the required strength level, heat treatment, and quality descriptors. You can read in here. Next is carbon steels. All steels are iron carbon alloys with carbon content from 0.02% to less than 2%. The so-called plain carbon steels contain small amounts of manganese and silicon. Okay, so we can see the classified further on the basis of carbon content, like steel containing less than 0.30%, that called low carbon steel. And then there are medium carbon steel, that the steel containing between 0.20 until 0.60% carbon. Next is high carbon steel, that containing more than 0.60%. The last is free machining grades. Next is alloy steels. Alloy steels contain higher level of manganese, silicon, or copper compared to carbon steels, or they specify range or minimum for other alloying elements like nickel, chromium, and molybdenum. Sometimes alloy steels are categorized as low alloy or high alloy depending on whether their total alloying content is below or above 8%. However, this distinction isn't strict, as some steels with slightly more than 8% alloying content are sometimes termed medium alloy. High alloy steels typically include stainless steels, merging steels, austenitic manganese steel, and certain ultra-high strength nickel steels. So, the general steels are categorized as low alloy or high alloy. We can see here in this table, low alloy steel that and high alloy steel. You can see how we make alloy steel in here. If low alloy steel, there are ferritic, pearlitic, martensitic, and benitic. High alloy steel is we can do with corrosion resistant, heat resistant, and wear resistant. Yeah, you can see there. Okay, next. Alloying element. Alloying elements in steel. Steel alloys represent one of the most intricate groups of alloys widely utilized. The combined impact of alloying elements and heat treatment generates an extensive array of microstructures and characteristics. So this is the element that we can use to make an element in steel, such as carbon, manganese, silicon, copper, chromium, aluminum, and others. Carbon is the single most important alloying element in steel. It is the principal hardening element. Manganese is normally present in all commercial steel. It is important in the manufacture of steel because it deoxidizes the melt and facilitates hot working of the steel. Silicon is one of the principal deoxidizer used in steel making. Copper adversely affects forge welding. Chromium is generally added to steel to increase resistance to corrosion and oxidation, to increase hardenability, and to improve high temperature strength or to improve abrasion resistance in high carbon composition. Aluminum is widely used as a deoxidizer and for control of grain size. Next is strength and toughness. Toughness. The most common measure of toughness is resistance to impact as measured in Karpy-V notch impact test. Carbon content generally increases the strength of steel, but this occurs at the expense of toughness, like in this figure. Consequently, many applications such as high-strength structural steels do not depend on just carbon alloying for strength. Fatigue strength. When a steel part faces repeated or cyclic stress, like vibratory stress, it can undergo fatigue failure, even if the overall stress levels on the part are lower than the steel's yield strength. Therefore, it's crucial to comprehend the factors affecting fatigue and its resistance, and to determine safe stress levels for a part exposed to repeated stress or strain. Next is elevated temperature strength. Carbon steels and low alloy steels with ferrite perlite or ferrite bainite microstructures are used extensively at elevated temperatures in fossil fuel fire power generating plants, aircraft power plants, chemical processing plants, and petroleum processing plants. Many applications, however, are even more familiar. These include components of automobile engines and exhaust system, home furnace and hot water system, toaster, and ovens. Next is corrosion. The metallurgical definition of corrosion is an electrochemical process whereby metal atoms exchange electrons with atoms in the environment. One of the most famous corrosion-resistant iron artifacts from antiquity is the Iron Pillar of Delhi, a 7-meter tall iron-based pillar that was constructed by the order of Kumaragupta near 400 AD. It remains, as this feature, as a testament to the skill and ability of ancient Indian ironsmiths and has attracted the attention of both archaeologists and metallurgists. Okay, I think that's all I can presenting about this topic. See you in the next topic. Thank you for your attention.